Good afternoon, and some of you still good morning. I am calling in from The Ohio State University, and it's my pleasure to be with you today. And I hope you have a good experience through this webinar. And thank you, Steve, for your initial presentation. I'm going to start with a few slides actually taken from Stephen Weller at Purdue University, just some thoughts about soils and weeds. I'm a soil scientist, not a weed scientist. But of course, weeds grow in soils, so you need to know something about soils. And so I'm going to talk at the beginning about some thoughts about soils and weeds. And some of this has already been covered very well by Steve. He talked about weeds are a symptom of a soil problem. If you have a lot of weeds, that means your soil isn't probably properly balanced as far as nutrients, as far as water drainage, all of these other things that we need to think about to make a good fertile soil. Weeds can also give insight into what the soil problems may be, and I really like that one slide Steve had saying that if you had certain type of weeds, you might have a compacted soil. If you have another type of weed problem, you might have a high pH soil or a poorly drained soil. So weeds can give insight into soil problems. Knowledge of weed indicators can allow modification of soil management practices. So if you know what these weed indicators are telling you, then you can begin to think about, well, what changes would I need to make to overcome these problems that the weeds are telling me that I have? And then soils, when properly managed, will grow better crops, and as a result, you'll have a lesser influence of weeds. And I put this in dark, bold letters at the bottom. Crops are wimpy. You know, we have produced seeds and crops over the years, and they're produced, the genetics are in such a way that they're created to make as much biomass, harvestable biomass as possible. But then as a result of that trade-off, we need to really kind of nurse them along and make sure that we try to remove as many impediments as possible to their growth. So I just put this note here. Crops are wimpy, and we need to try to make sure our soil is managed as much as possible to allow the crops to grow and compete against the weed pressure that would be in that soil. And I lost, there we go. I guess you'll have to, okay, there we go. Oops, now it went to 2. So features of a good quality soil. These are things that we would look at. Is the soil soft and crumbly? That's, sometimes people use the word tilth. Does the soil have a good tilth? Hopefully no hard pans. Is it well drained? Does it warm quickly in the spring? Does it infiltrate the water, the heavy rains that come? You know, we want the water to go into the soil, not to run off from the soil. Does it resist erosion and nutrient loss? If we have nutrient losses and erosion from our soils, that erosion is taking our best soil and removing it and putting it in the bottom of a pond or a river, and that's obviously not what we want. Does it have a high population of diverse, beneficial soil organisms? You know, even a poor quality soil could have very high populations of organisms, but they might be the wrong type, and only maybe a few species. In a good, fertile soil, we want a soil that's very diverse in the types of organisms and has the right type of organisms to feed the soil, feed the plant, and produce a very healthy crop. Has good high nutrient holding capacity. That's a cation exchange capacity, of course, high productivity, and free of harmful contaminants. So the features of a poor quality soil are as followed. You know, compacted soils, poor aeration, roots need air, so if you have a compacted soil, they're not getting enough air, they cannot breathe. Has low nutrient holding capacity, so any nutrients you might apply to that soil tend to be leached. They're not held in the soil the way they should be. Low organic matter. A very easy way to determine if you have a good quality soil or not is, are you building organic matter or are you losing it? And then, of course, coming back to that microbial population, a poor quality soil lacks a diverse population of soil organisms. And one way we can tell very easily if we have a good quality soil or a poor quality soil is just to begin to dig up some plants and see how the roots are distributed in the soil. If they're all, right at the surface, they're not going down deep. You might have a hard pan. You might have acid in the soil, in the subsoil. It just tells you have a problem, and you need to pay attention to those roots and then ask the question, what is it that's causing this poor root growth? And if you can identify those issues, then you can begin to take action to overcome the problems that are associated with that poor root growth. So I was asked to talk today about gypsum. I've done a lot of work on gypsum. There's a lot of interest on gypsum and using gypsum as a soil amendment. So I'm going to talk a little bit in general about what is gypsum and then some of the benefits it can apply to soil to make a good quality soil. And then you that are interested in weeds and that part of it, I said I'm not a weed scientist, I'm a soil scientist. Hopefully you can put the dots together after I finish my presentation. But gypsum is a very soft mineral. It's composed of calcium sulfate dihydrate. And you see the chemical formula, calcium sulfate with 2 waters. It's a very good source of 2 nutrients, calcium and sulfur. And because it was quarried from a certain district near Paris, burnt gypsum, this material sometimes has been called, or it's just one form actually of gypsum, called plaster of Paris. It's moderately water soluble, and that's important because if you apply calcium in the form of lime, that calcium is relatively insoluble. But the calcium in the form of gypsum is much more soluble, actually 200 times more soluble than the calcium in lime. Next. So just some history. It's not a new material. Gypsum has been used in agriculture literally for thousands of years. Early Greek and Roman times. There's a story out of France, people that were creating this plaster of Paris, they would come home with all this dust on their clothes, and their wives wouldn't want them to come home into their houses with all this dust on their clothes, and so they would make them shake off the dust on their clothes. And they found wherever they did this, and they would do it basically the same place every night, they saw the grass was greener. And that was a very curious observation, but it was one of the earliest indications that the calcium and the sulfur in gypsum had some really good benefits as far as growth of grass and plant growth in general. And it became quite extensively used in Europe in the 18th century. In 1922, a scientist named Dr. William Crocker, and these slides will be available for you to look up later on. You can look up this publication, but he gave a history of the agricultural use of gypsum in the United States, in the colonies really. It was published in 1922. It's a very nice summary and introduction really of the whole use of gypsum in agriculture. There were several names he mentions in that article, but I just have to tell you a few because it makes a nice, interesting story. You know, one of our very early revered scientists in the United States was Benjamin Franklin, actually one of the world-renowned scientists in his day. And he had done some experimentation with gypsum, and actually some other studies were commissioned by George Washington at this time. And what he did is he took gypsum and on a side of a hill spelled out the letters with his gypsum, "Land plaster used here." And so as farmers would drive by in their buggies along the road, they would see this side of this hill with these words spelled out, "Land plaster used here." It was a great advertisement for the use of gypsum. And gypsum at that time came out of Canada, and again was one of the few fertilizer materials, natural materials, that was available to these early farmers in the colonial period. So what are some of the benefits of gypsum in agriculture and that can provide a good quality soil that then can grow a crop that can compete against the weeds? Well, I've already mentioned it's calcium sulfate, so it's an excellent source of calcium and sulfur for plant nutrition. It's a source of sulfur and exchangeable calcium to ameliorate or improve subsoil acidity and aluminum toxicity. You know, in acid soils, it's not the pH that's toxic. It's aluminum ions, aluminum 3+, that becomes very available under acid conditions. And it takes just a very small amount of this aluminum ion to be toxic to plant roots, so that plant roots really can't grow in the soil and explore the soil volume for nutrients and water. So gypsum tends to overcome this aluminum toxicity issue. I have to say right up front, because I get this question all the time, and it's a misconception. Gypsum is not a liming material. It does not change the pH of the soil. It can improve the properties of an acid soil, but it doesn't really change the pH. And so I want to make that very clear, because that's an issue that comes up over and over again, a misconception. It is not a liming material. And in all reality, I like to advise farmers, if you have an acid soil and you're interested in using gypsum, the combination of the two makes a perfect pair, applying lime and gypsum together. Gypsum can flocculate clays to improve soil structure and reclaim sodic and high phosphorus and magnesium soils. Gypsum has been used literally for hundreds of years around the world to reclaim soils high in sodium, and also if there's a little bit too much magnesium in the soil, and improving the soil physical properties. It can help promote the formation of organic matter, calcium humates in soil, and as a result then it can improve overall soil and water quality. So I'm going to start with benefit number 1 of gypsum: calcium and sulfur source for plant nutrition. That's the first benefit we're going to look at in just a little bit more detail here this morning. I like to say calcium and sulfur are the forgotten nutrients. We pay a lot of attention to nitrogen and potassium and phosphorus, but you can see here calcium is actually required at a very high level, even more than phosphorus. And sulfur is also one of those macronutrients required at very high levels. And, you know, one of the things that has happened in this country, the Clean Air Act, the federal government has mandated that when we burn fuels to produce energy, that we have to scrub the gases that come out. Many of these gases, of course, contain sulfur dioxide. And so we were getting free sulfur every time it rained for many, many years. When these scrubbers came on board and the sulfur was removed instead of being put in the air, we no longer got free sulfur. Every year when we harvest hay, we harvest corn, harvest vegetables, we're removing sulfur, but we were not replenishing it. And so now we're seeing more and more and more reports of farmers and researchers saying, you know, we are finding that our soils are becoming deficient in sulfur, and we need to replace that sulfur. And gypsum is an excellent source of sulfur as a fertility element in our soils. So this is just showing some benefits here. This is corn. Applying gypsum at 30 pounds per acre of sulfur. That's enough to replace what would be removed by most crops. And we see a very significant beneficial impact of the gypsum. The yield of corn was highly and significantly increased where we added the gypsum compared to where we did not add the gypsum. And we're finding this, like I said, more and more commonly. We don't find it every field, everywhere, every year, but it is becoming something we see more and more common. This shows the effect of gypsum on alfalfa yields here in Ohio. This is a 3-year cumulative alfalfa yield image or graph. And you can see again, we applied gypsum at the same rate, 30 pounds per acre of gypsum as a sulfur source. And we saw a highly significant improvement again of the yield. And we are finding in Ohio, at least, that we are almost always finding a response of gypsum when we apply it on our forages, sometimes on corn and some of the other crops, but the forages really respond well to this gypsum application. Not only does it improve the yields, it also improves the quality of crops that are grown. Vegetable crops, forage crops. This is a study out of Scotland showing sulfur without, well, actually daily sheep gain that was being fed alfalfa. And when they were being fed alfalfa where there was no sulfur applied, which is the 2 bars on the left, you see that the rate of sheep gain. And then if you go to the right where you were applying about 60 pounds per acre of sulfur as gypsum on the right, if we didn't apply nitrogen, we still could not take advantage of that sulfur, and the quality of the forages really weren't improved that much. But when we had both sulfur and the nitrogen requirement being met by that crop, that's when we got a very high quality forage, and the sheep gain was very, very highly enhanced. And so this sulfur is very important to improve the quality of what we produce. That's because sulfur is an important element in making proteins and amino acids. And if you don't have enough sulfur, you cannot produce those proteins that are part of a good quality forage or part of a good quality food material in general. I'm going to also talk about sulfur and calcium as a way to ameliorate subsoil acidity and aluminum toxicity. So here in Ohio and other states, farmers will lime the topsoil, the top 8 inches, raise the pH to 6.5, but many crops have roots that will go much deeper than 8 inches. And if that soil is much lower in pH, and as we find many times a pH of 5, 5.1, 5.2, sometimes even lower than 5, 4.8, 4.9, that soil is too acidic. It creates aluminum 3+ ions, which are toxic. And so the roots all tend to stay in that surface layer. And then when the hot, dry weather comes, they suffer from lack of moisture. Any nutrients that are deeper in the soil profile, there's no roots there, and so the crop can't take up those nutrients. So it's really important, can we try to improve our soil even below the plow layer, so to speak? And gypsum is one of those treatments that we have found can help do that. So what happens? Well, you apply this gypsum on the surface. You could till it in, but let's say you apply it on the surface. It's 200 times more soluble than lime, so the calcium can move down into the soil profile. It exchanges with the aluminum 3+ ion, which then gets kicked off and leached out and removed from the soil. So that's one way to remove this toxic aluminum ion. The sulfate also can help overcome the aluminum toxicity, because what it does, it complexes with the aluminum to form an aluminum sulfate complex. This aluminum sulfate complex is not nearly as toxic as the aluminum 3+ ion. So now we've had 2 mechanisms of how that gypsum, as it moves through the soil profile into that acid subsoil, that does not change the soil pH, but makes that soil profile in that acid subsoil so much more friendly for roots to grow. And as a result, then we get much more root growth in the soil subsoil, and much more root growth in the subsoil. And if we have more root growth in the subsoil, as I mentioned, when it gets dry and hot, they're still able to pick up water in the deeper layers, still able to take up nutrients in those deeper layers. So I don't know if this cartoon will We'll demonstrate, hopefully I will on this webinar, but what it is, it's a little cartoon that shows calcium sulfate applied on the surface of the soil, and you have this aluminum down deeper in the soil surface on these clay platelets. When you apply the calcium, it begins to move down. So let's see what happens. If we can see, there we go, the calcium moves, kicks off that aluminum, kicks off the aluminum. Some of the aluminum gets bound up with the sulfate. The aluminum sulfate is non-toxic, whereas the aluminum itself is toxic. So here's the next slide. I'll just go to that directly. Here's a soil, brown soil, common in Ohio. The surface has been limed, so the top 20 centimeters, which is 8 inches, has a pH of about 6.5 right at the surface. But then if you get into subsoil, down to 40 centimeters, which is 16 inches, you see the pH has dropped below 5.0. At that low pH, aluminum 3+ becomes a problem, and you get just the mirror image. At high pH, aluminum 3+ is not a problem. As you lower the pH, it becomes a problem. And roots don't like that. So where are all the roots going to be? Well, we'll see that in a little bit, but well, actually, we'll see this here. At the top, we see that reaction, the sulfate, calcium sulfate, plus the aluminum ion, forming the aluminum sulfate complex, which is non-toxic, plus the calcium. And this is a study that was done where soil was limed and where soil was limed plus gypsum added. The soil that was limed, that yellow-green color there, where are all the roots? In the top 8 inches. Where do we want the roots? We want the roots to go much deeper, obviously, than that. And so if we apply the limestone plus the gypsum, we've overcome two things. We've overcome the surface acidic problem by adding the limestone. The pH is still up 6.5. That's right where we want it. But that gypsum application is very soluble. The calcium is very soluble. The sulfate is more soluble. It begins to move down. It counteracts that toxic aluminum ion. And now where do you find all the roots? Much, much deeper. 16, 20 inches down, a bulk of the roots. This is a good, high-quality soil. This is where the crops now can take the nutrients, get the water, and begin to really compete against any weed invasion that you might have in your soil. Finally, I'm going to talk about flocculation of clays to improve soil structure and reclaim sodic and high phosphorus and magnesium soils. So this is one of the other things when we talk about gypsum and some of the work I've been doing in Ohio. This is really a major research emphasis at this point in my program. So we have magnesium in clay, and magnesium is absolute required cation. You need it. It's required for good crop growth, and so I don't want to disparage magnesium in any way, but what magnesium and also sodium does, it takes water and it hydrates that magnesium ion and makes it a very bulky ion, very bulky. And when that happens, in the clay particles that would be surrounding the magnesium ion have a negative charge and the magnesium has a positive charge, those clay particles can't come together. And so what happens, the clay particles are actually dispersed into individual particles, and when that happens and you get a rainfall event, those clay particles then get into the micropores and they clog up the pores, and you get a crust on the surface, and you have really a hard time having the water infiltrate into the soil and the soil to be properly aerated. Now, calcium, on the other hand, what happens there is the calcium positive charges, 2+, takes those negative charges on the surface of the clay particles and brings those clay particles together to make small, tiny microaggregates. And those microaggregates then combine into larger aggregates. And when this happens, you have a much more porous soil, and you have a much better quality soil as far as physical properties in terms of allowing better aeration of the soil so the roots can grow better, and much better water infiltration. And we have several really nice pictures over the years where we have side-by-side demonstrations when we get a heavy rain. The soil that has been treated with gypsum very little water ponding on that soil, soil that had not been treated with gypsum, you see the water being ponded. And so this is one of the other benefits that we are studying and has been observed as we use gypsum. And where's my arrow to advance? It's not showing. There we go. So this shows infiltration. This was actually done by Dr. Daryl Norton. It's not my work. I have to give him credit. But you see at the bottom, there's a curve of water infiltration rates in the control soil, and it's anywhere from 2 to 4 times less than the water infiltration rate in the soil that's been treated with gypsum. And so this is just another piece of evidence of how that gypsum treatment on the soil surface is really important. You know, the soil surface acts as a valve, and you want to keep that valve open for water and air. And if you don't keep it open, you have what you see at that bottom, very poor water infiltration. Gypsum helps keep that valve open at the surface. The other thing, of course, if you have water infiltration occurring, you're not getting as much runoff. So this is from also Dr. Daryl Norton. You can see the runoff in the control area versus a gypsum-treated area. The runoff has been decreased because the water is actually getting into the soil. The erosion has been actually more than 50% or halved, much less than half the erosion in the gypsum-treated area versus the control area. And then probably this isn't so pertinent here in this webinar, but the soluble reactive phosphorus that gets into our water bodies, Lake Erie, that's actually reduced by about 60 to 70% because the calcium reacts with the phosphorus. So these are some of the things that we are seeing as we do our studies with gypsum. I have a written bulletin, was published in 2011. You can get it from the Ohio Extension Service, called Gypsum as an Agricultural Amendment, General Use Guidelines. There's a lot of things, a little bit more detail than I've just talked about in summary this morning. But I've also showed you the website there, or just go search for Ohio Line. It used to be free. You could download it for free. Unfortunately, Ohio State now has put a price tag on it. It's been very popular. I think they've sold maybe over 3,000 copies. But just if you're interested, you can get a hold of one of these. I think it's like $5 to get a hold of a copy of this bulletin. And just one last thing about gypsum, just to show it's not something just I'm talking about, and I'm one lonely voice in the wilderness talking about gypsum. You know, our professional scientific society, American Society of Agronomy, they actually have a group of scientists. We call ourselves a community across the United States and really around the world. This community is called Byproduct Gypsum Use, and really it's gypsum use in general, gypsum use in agriculture. And we have seminars, we interact with each other, trying to really bring this issue and as much knowledge to this issue as possible. So in conclusion, let me say this about gypsum, and this is what I was asked to talk about this morning as regarding weeds and soil quality. And again, hopefully you can connect the dots because I'm a soil scientist, not a weed scientist. But gypsum as an agricultural amendment can provide multiple benefits, including improved crop production via better soil quality. It reduces soil erosion, so you can keep your high quality soil where you want it to be in place. And then this last one is something we're working on today, but more and more today, reducing phosphorus movement off of our agricultural fields, keeping it in the soil where we want it, not in Lake Erie, other places where we don't want it. So we say this is a win-win-win situation for us. And thank you. I appreciate your attention this morning.